Okay. I want to, this is another tutorial on how to solve for exponentials, but a couple of harder ones where it involves using some progressive exponents and logarithmic differentiation to solve. Examples of problems like this would be like when you have y equals x to the x power, okay, x to the x power. Here we have, we do not have a traditional exponential function, okay? We have x to the x, so we have a base, which is a variable, and the exponent, which is a variable. You cannot solve this using the power rule or exponential differentiation. You can't do that. What we're going to use is we have to change this and use the progressive logs to solve it. So to find this derivative, what we're going to first do is we're going to get this exponent, this variable out of the exponent. To do that, we're going to log both sides. When we log both sides, what happens is we have the natural log, and I'm going to natural log because natural log is when you get the calculus, you use it all the time. So you have a lot of ease. We're going to use natural log of y equals natural log of x to the x power. By doing this, what we're going to do is we're going to now take, and we can move this x using progressive logs, the power property, and move it to the front. So we have x natural log of x. From here, we're now going to differentiate this with respect to x. Now, to do this, we have to take the derivative of y, natural log of y. Now, if you don't know from the previous tutorials, that the derivative of the natural log is 1 over the inside, which is y. But in this case, we can take the y derivative, which is dy dx. We're now going to take the derivative of x times natural log of x. Right? X times natural log of x. Well, now the derivative of x is times natural log of x, plus now the derivative of natural log of x, which is 1 over x, times x, and that's going to be our derivative. All right? We're going to simplify this because we're going to solve for dy dx. So we're going to have this right here. I'm going to have dy dx. We're going to have natural log of x plus 1. We're going to multiply both sides by y. Let's simplify this a little farther. We know that y actually equals x to the x power. So we're going to have natural log of x plus 1 times x to the x power, and that would be our simplified derivative. All right. Well, let's try another one of these. All right, another one. Let's say we have, I don't know, yeah, let's go y equals x to the natural log of x. X to the natural log of x. Now, this one, we're going to find this, and we're going to have to, once again, we have a variable, which is x. We have the exponent, which is x. So we can't solve this with traditional methods. So we're going to use logarithmic differentiation. Logarithmic differentiation. So I'm going to do natural log both sides when I solve this. When we do that, we have the natural log of y equals the natural log of x, natural log of x. And I'm going to change that. So now I'm going to have the natural log of y, put the natural log in front, and now we have natural log of x. All right, so we have natural log of the natural log times the natural log of x, which is, could be, I guess, natural log of x squared. We're doing that. So from here, what we're going to do next is we are now going to differentiate this. Okay. By doing so, what we're going to have is 1 over y times y prime. I'm not going to make it square. I'm just going to keep it like this. I'm going to take the derivative of natural log of x, which is 1 over x times natural log of x. I'm going to add that to, once again, 1 over x times natural log of x. And there we have it. We can add these together and multiply. Oops. Down here. All right. We can take this, and now we're going to solve for y prime. Y prime equals, we have 2 of these, so we're going to have 2 over x, natural log of x. We're going to multiply this by y, and our y, if you recall, was y equals x to the natural log of x. So we have 2 over x, natural log of x, times x to the natural log of x power. And there we have it. That is our derivative. Okay, well, hopefully this helps you out. I'm going to do one more. All right, and we're going to put in a trig one here. So we're going to have y equals, let's see, x to the sine of x. X to the sine of x. Okay. Solving this one, same thing. We have x in the base, x is the exponent, so we can't solve a traditional method, so we're going to use logarithmic differentiation. We're going to log after log both sides. When we do that, I'm going to just watch the preceding ones. We know we're going to write it like so. It's that, and we're going to have it like that. Okay? Take the derivative, differentiate. We're going to have 1 over y prime. It's going to equal the derivative of sine, if you use the product rule, which is going to be cosine of x times natural log of x, plus the derivative of natural log of x, which is 1 over x, times sine of x. All right? And then we're going to simplify this a little bit farther. We get y prime by itself, so we have cosine of natural log of x plus sine of x over x. That's all multiplied by y. Y we know is x to the sine of x, so we have our final answer cosine. Oops, got my x right there. Cosine of x natural log of x plus sine of x, x sine of x. Bada bing, bada love boom. All right. So this was using logarithmic differentiation. Logarithmic differentiation to solve these type of problems. Hope this helps you out. Whenever you have a base which is x and exponent which is x, these are some cool things to help you solve.